Welcome back, everyone. We're going to be solving LeetCode 69, square root of x. So we're given a non-negative integer x. We want to return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. And we must not use any built-in exponent functions or operators. And they say, for example, we can't use the power of x to 0.5 in C++ or x star 0.5 in Python. So we can solve this using binary search. We can start left at 0, right can be initially set to x. And while left is less than or equal to right, we want to calculate the midpoint. The midpoint is going to be left plus right minus left, floor divided by 2 to avoid integer overflow. Now we need to calculate the square root, essentially the point that we're at. So if we're looking for 4 and m is 2, 2 times 2, if that is equal to our original input x, that means we have found the square root, and we can just return our midpoint. Else if m times m is less than x, then we have to move our left pointer 1 ahead of our midpoint. So midpoint plus 1. And else if mid times mid is greater than our x input, then we have to move our right pointer down 1 from our midpoint. And then if we ever exit this loop, meaning we haven't found this, we can just return the right pointer. And let's run this. Right is not defined. Right, R, not right. We passed both test cases, so we'll submit. And we see that it does run. So we'll come back here. The runtime of binary search, which is what this algorithm is going to be O of log n. And the space complexity, we're not using any extra data structures, so we are going to be O of 1 for space complexity. And that'll do it for LeetCode 69.